Okay, so today we're going to be talking about factoring. So to start off this lesson, we're going to do an activating strategy. I want you to divide up into two groups, and we're going to use the FOIL method to multiply out binomials. So I have a sheet of problems, and I have squares of terms. And by using the FOIL method, I want you to figure out what the answer is. If y'all want to get up and move around and do it in the floor, just spread out and lay out your equations, and then the first group to complete it gets 3 extra credit points on the quiz.
You can leave it there, she said. I'll leave it. I'm just trying to clean it.
So we're going to go over 2 essential questions. I want you to be thinking about these while I'm teaching the lesson. In general, how do mathematical operations relate to each other? And how might the ideas of factoring be used in real life? So you can't really answer the second question yet because you don't know what factoring is, but does anybody have any ideas about general mathematics and how mathematical operations relate to each other?
There's different ways. One operation can make another operation shorter, easier.
Okay.
Uh,
Okay.
So you can, it makes the problem easier. So
Okay.
easier to solve, or takes, I guess you can say, sort of like a load off, so you don't have to think real hard
Okay.
about it.
Well, things have like opposites, like adding and subtracting.
Right.
And multiplication and division.
Multiplication, division. For this lesson, especially think about the opposite of multiplication. Okay, so for this lesson we have essential vocabulary that we need to know. So with your technology, I want you to look at these terms. What is a polynomial? What is factoring? What is a factor? What is the quadratic equation? And what is the factored form? You will probably be able to find these two together. So what is the factored form of the quadratic equation? So with a partner, go ahead and work on these vocabulary words together. Talk amongst yourselves. Okay, since most of y'all are about done, I'm gonna go ahead and start going over. Okay, so who wants to give me their definition for a polynomial? Anybody wanna raise their hand? It has 2 or more terms. So a polynomial is a mathematical expression comprised of 2 or more terms. So term is gonna be any single digit and possibly a variable that is separated in a mathematical expression by a plus or minus sign. So a term, in this first example, you have 3w squared minus 10w plus 8. A term for this example, 3w squared is a term, negative 10w is a term, 8 is a term. Altogether, you have a polynomial expression. Polynomial, poly means many, and nomial means the term itself, so many terms. In this one you have n squared is a term, and then negative 9 is a term. Altogether you have a polynomial. My next term was factoring. Who wants to give me their definition of factoring? Anthony.
We found it to be the process of separating an equation.
Okay, so what does that mean?
It's like, for example, of taking what you described a polynomial in the very beginning and separating it into 2 smaller equations. So like, for example, we have, as you give it up there, taking 3w squared minus 10w plus 8, separating into w minus 2 and 3w minus 4.
So to express a polynomial as the product of monomials and polynomials. So a monomial is the term that is just 1. So just 3w by itself would be a monomial. Mono means 1. Polynomial is more than 1 term, so 3w minus 4 is a polynomial because it's got 2 terms. So the rule of thumb for factoring is that once you have separated all of your combinations of terms out, you cannot have a variable with a degree higher than 1. So when you look at W or you look at 3W, you know that the exponent on the W is 1 here, and it's 1 here, and it's 1 on the end, and then it's 1 on this end. What is the degree of this 3W squared?
To the second power.
Yeah, so when you factor this out, you want to make sure that that W becomes a combination of 2W terms. What is a factor? Who wants to give me their definition of a factor? Cameron?
A factor is a number or quantity that when multiplied with another produces a given number.
Okay, right. So if you have a number multiplied together to get another number. So when you think about factors, you want to also think about prime numbers and composite numbers. A prime number, does anybody want to give me what they think a prime number is?
Only has 2 factors,
And those factors are?
itself and 1,
Right. And a composite number is what?
more than 2 factors.
More than 2 factors. So an example of a prime number might be 7. You can only get 7 by multiplying 1 in itself. A composite number, at the bottom you can see 9. So what are your factors of 9? You can multiply 1 and 9, but you can also multiply 3 and 3. Who wants to give me their definition of a quadratic equation?
I have like just the standard form of ax squared plus bx plus c.
Okay, so that is the general form you'll be given when you factor. You will get ax squared plus bx plus c. Today we're going to look at examples where a is 1, so you can ignore that a component, but a, b, and c will represent constant terms. They're coefficients of your x variable. X squared and x represent variables. An example of a quadratic equation might be 2x squared plus 2x plus 1, where your a term is 2, your b term is 2, and your c term is 1. And then you have the same thing here. Your x squared is going to be a variable, and then your x is going to be a variable in your 2x. So as you progress, you realize that whatever that x is raised to, that's how many sets of parentheses you have. So if you had x to the 3rd power, you would have how many parentheses? 3. What is a factor form? Does anybody want to give me their definition? Anybody? No? Okay, a factored form is just going to be what you get when you factor out your polynomial term. So you have x plus e and then x plus d, where your e and d are real numbers, and then your x, again, is a variable. So we were looking at problems where you had x squared. When you factor that out, since you have x squared, you'll get 2 x's. Whatever your degree of your leading term is, will be how many x's you get when you factor it out. So an example, 3x minus 1 and then x plus 1. These quantities are multiplied together. You can have coefficients on either of these x's. So we have been working with problems where we would multiply these out. You would multiply using the FOIL method. But factored form is also what you called this before you use the FOIL method to multiply it out. So what is factoring? Essentially, you have to move from the formula ax squared plus bx plus c down to a factored form, which is represented x plus d times x plus e. So a, b, and c, like I said, represent any constant coefficient, and d and e represent any constant coefficient. X is a variable, which you don't know, but you put it into the factored form as an x here and an x here, and because it's x squared, you only have 2 x's. So you have to ask yourself, how can we think about this? So essentially, we are going to be undoing the FOIL method. So you have to ask yourself, how do you multiply backwards? When you have your polynomial, you are looking at the factors of your numbers, your coefficients of those numbers, and how do you get down to that factored form of your mathematical expression? So think about what you know about binomials. if you are given the form x plus a and x plus b, I just denoted x1 and x2 just to say that they were, you know, two different things. Cause you may have different coefficients in front of those x's. You know that you get the first term by forming, the product of x1 and x2. So if you multiply x and x together, what are you gonna get?
X squared.
X squared. And you get your second term by summing the product of ax and bx. So if you use the FOIL method like we've been doing, you have your outside terms, your x1 and your b, you multiply those together, and then you multiply your inside terms, and that's a and x. And then since x is a like base, you can add those terms together. So normally in an equation you have a and b are numbers, so you're actually able to add those together, but you get ax2 plus bx1. You also need to think about the product of signs. So if you multiply a positive and a positive together, what are you going to get?
Positive.
Positive. If you multiply a negative and a negative together, what are you going to get?
Positive.
Okay, and when you multiply a negative and a positive,
Negative.
and when you multiply a positive and a negative. So, like I was saying in the previous slide, you have to consider the factors of your last term. So, you also have to consider that sign that's hooked on the front of it. If the sign is a positive, you know that the factors multiply together to get that number may be a positive and a positive, or it also may be a negative and a negative. When you have a negative hooked on the front of that C term, it can be a positive and a negative number. So factoring. Essentially, you're going to be given an equation that looks like this first bullet point right here. You'll have x squared plus bx plus c. So you have to ask yourself, what two factors multiply to give you c? And then you have to add those factors together, and they will give you b. When you find your two factors that give you c, and then they add together to give you b, you put those two factors into your parentheses with the signs that are associated with them. So that's more easily explained by showing you problems. I'm going to work through these problems real quick. Okay, so for this first problem, you have x squared plus ax plus 15. So from the previous slide, you set up the table where you said, what are your factors of c, and then the sum of those factors. So you have positive 15. What are your possible factors?
1, 15, 3, and 1.
And because it's positive, what are your other possible
You have the
factors?
negative of the
Negative, so negative what?
negative 1 and negative 15, negative 3 and negative 5.
So when you sum these factors, what do you get when you add together 1 and 15?
16.
What do you get when you add together 3 and 5?
Hey.
What do you get when you add negative 1 and negative 15? And when you add negative 3 and negative 5? Negative 8. So when you look at your B term, which of those two factors give you positive 8?
3 and 5. Positive 3 and 5.
Right. So if you are looking to get this form, what am I going to add to those parentheses?
3 and 5. Positive 3 and 5.
So,
Plus 3 plus 6.
okay. So I can go back and check that by multiplying this out with the FOIL method. So walk me through that. What do I get?
X squared.
Mm-hmm. What do you get when you multiply together?
Plus 3x.
Yeah. And
Plus 8.
plus 15. So if I simplify that down, I get x squared plus 8x plus 15. And if that's what I originally started out with, I know that my set of parentheses is correct. And while I'm doing these problems, go ahead and copy these down in your notes. So if my second problem is x squared plus 11x plus 24. And I have factors of c and the sum of those factors. What is c for my second example? 24. So, what are the factors of positive 24?
8 and 3, or 1 and 24.
1 and 24. And
3 and 8.
3 and 8.
4 and 6.
4 and 6.
2 and 12.
2 and 12. What else? Since it's a positive 24.
Negative all of those.
So I also have the negative of all those. So negative 1, negative 24, negative 3, negative 8, negative 4, negative 6, and negative 2, negative 12. So when I add these together, 1 plus 24, what do I get?
25.
25. 3 and 8,
11,
6 and 4,
10,
2 and 12,
14,
negative 1 and negative 24.
Negative 25.
negative 11,
Negative 4 and 6,
negative 10,
and then negative 2 and negative 12.
negative 14.
So, which of those factors did I use to get my B term? What is my B term?
Negative 11.
Okay, so which of those two factors?
Negative 3, negative 8.
Negative 3 and negative 8. So, what do I put in my parentheses?
You accidentally wrote plus 11x on the side over there in your equation.
Thank you.
You're welcome.
What do I put in my parentheses?
Minus 3 and minus 8.
Minus 3 and minus 8. So if I multiply this back out to check my work, what do I get?
X squared minus 3x minus 8x plus 24.
And if I simplify this, what do I get?
X squared minus 11x plus 24.
And is that what I started with for my second equation?
Yes.
So you know that x minus 3 and x minus 8 are the. For my third equation, I have x squared plus 2x minus 15. So what are my factors of c and the sum of those factors? So factors negative 15. So when you have a negative as your c term, what are you multiplying together?
Positive.
A positive and a negative. So what are my possible factors? Just think about first, what are your factors of 15, just in general?
1 and 15 and 3.
Right, so you have to have both the negative combination, negative positive, and then positive negative combination of those two. So positive and negative combinations. Go ahead.
Negative 1 and 15. Negative 3 and 5. 1 and negative 15. And 3 and negative 5.
So if I add those together, what do I get when I add negative 1 and 15?
14.
What do I get when I add negative 3 and 5?
2.
What do I get when I add 1 and negative 15?
Negative 14.
And what do I get when I add 3 and negative 5?
Negative 2.
So, which of those combinations give me my positive 2x term? Negative 3 and 5. So, if I have x and I have x, what do I put in my parentheses?
Negative 3 plus 5.
And that is also the same as this. So if I'm gonna multiply these out to check my work, what do I have?
X squared
X squared
minus 3x
minus 3x
plus 5x
plus 5x
minus 15.
minus 15. And if I simplify that,
X squared plus 2x minus 15.
and is that what I started with in my original
Yes.
problem? Yes. With the person beside you, go ahead and work out the problems on your worksheet in this form. Is the same form I've been using on the board, where you write your problem, which your problems will be on the next slide. You have this chart on your worksheet, and then under here you have your X parenthesis and X parenthesis, and then I also want you to go back and check your work with the FOIL method. So, I'll give you about 10 minutes to work on those problems. Okay, so we are going to go over the solutions. Who wants to come up on the board and work number 1 in this form? Sure. We're gonna go back and forth, so whoever starts, the other pair is second. Or we'll just go around the table. So we're gonna go back to the essential questions that I asked you at the beginning of this lesson. So how do mathematical operations relate to each other? Initially, we talked about general relations, but I want you to think now more about how the FOIL method and factoring relate to each other. So does anybody have any comments about how factoring and the FOIL method relate to each other? They're opposites. What else? Think about the terms, how you get the terms. If you have your polynomial expression, you have your A term, B term, C term. How do you get each of those terms?
One you're combining the terms and the other one you're distributing.
Right. So how might the ideas of factoring be used in real life?
So imagine this. So imagine you're looking at a problem and you think, wow, this problem's really hard. But just like in life, if you break down that problem into smaller steps, you'll find ways to go about it, and that'll be less stressful. You can use that in life and when you're solving a math
And
equation.
math, okay. So that's right. You are using critical thinking when you go through these math problems. You are given this big idea, you have to go through all these little itty bitty steps to come to your solution. That's kind of the general idea for math in general. How do you use all these small processes? How do you use all these small steps? And how do you use everything that you've learned to come together and solve your problem? So for your exit ticket, I want you to solve this problem. You have x squared plus 2s minus 35. So what factors give you negative 35, and what factor combination can be added together to give you a positive 2s? I'm going to give you about 30 more seconds. Okay, who wants to give me what they got?
I got s plus 7 times s minus 5.
That's right. So you said s plus 7 and s minus 5. So 7 and 5 can be multiplied together to get 35, but if you have a negative 5 and a positive 7, that gives you negative 35. It also adds together to give you positive 2s.